Hello, Matthews Gatos here. Welcome back to 6.3 part 2 where we're going to do word problems. But before we do that, let's get started on reviewing a multiplication question. Now this is a review question, so I do recommend that you pause the video, do the question yourself, and check the answer. Little typo in your notes. Lowest common denominator is chosen from category 2. And the simplified numerator chosen from category 1. So if you can make that adjustment in your notes. So go ahead, pause the video, try this question, come back and see the answer. So in this question here, I'm given an adding question and I'm given possibilities. It's another coding question for lowest common denominator, the numerator, and non-permissible values. So let's go ahead and solve this question by beginning to factor the denominator. So this is a perfect square trinomial, which factors as x plus 1 times x plus 1, plus the other one is a difference of squares. So I need to find the lowest common multiple, which will be one of each factor. So I need an x plus 1 and another x plus 1 because it comes from the same fraction. And I will also need an x minus 1. I don't need 3 x plus 1s because remember it's one of each factor to the highest exponent, which would be here squared, and here to the exponent of 1. So my lowest common denominator is x plus 1 times x plus 1 times x minus 1, which would be code option number 4. So that would be in this place here. Okay, the non-permissible values are going to be positive and negative 1, which will be this code right here. So all I have to do is simplify this and find what the numerator is. So let's create an equivalent fraction, which will have a lowest common denominator of x plus 1 times x plus 1 times x minus 1 for each one. And then I'm going to create equivalent fractions. There we go. Okay, so in my first fraction, I am missing a factor of x minus 1. So I'm going to multiply top and bottom by x minus 1. If I do it to the top and the bottom, I haven't changed the value of the question. So this will be 2x minus 2. Over here, plus minus, I'm missing a factor of x plus 1. So I'll multiply top and bottom by x plus 1. So that's x squared plus x. So I'm going to kind of write this backwards, but let's add these together. So I have x squared, and then I have 2x plus x is 3x minus 2 all over x plus 1. And really, I could write it out twice or just abbreviate it by doing squared and then x minus 1. So my simplified numerator is going to be this one here, which will be 1. So my code will be 4, 1, 7. That doesn't really look like a 7. There we go, 7. Okay, so let's get into doing some word problems. I have 2 word problems in this video. So in the first one here, we have a marathon runner breaking her 12K training into 2 parts. The first part is the warm-up, and it's done at a constant speed. The next part of her run, she will increase her speed by 1 kilometer an hour. I want to write and simplify an algebraic expression for the total time of her run. And just a little hint there on the side that time is the ratio of distance over speed. So what I'm going to do is split her run into the 2 parts, the warm-up and the run, and that will be her total run. Now, her warm-up, we don't know the distance. I know that there is 12K in total, and the running part is 8K. So the running part is 8K, which means the warm-up must be 4, because 4 plus 8 is 12. Now, that's the distance. Let's figure out the speed. The first part, the warm-up, is done at a constant speed. So I don't know what that speed is, but it's constant. So I'll just call it x. The next part, she increases her speed by 1 kilometer an hour. So whatever it was before, which is x, she increases it by 1. So this will be the total time for her run. The time for the warm-up plus the time for the run is the total time. So let's simplify that algebraic expression. So first thing I need to do is come up with my lowest common denominator, my lowest common multiple. So lowest common multiple between x and x plus 1 is 1 of each factor. Now as soon as I've done that, I can do my non-permissible values. So here I actually have triple trouble. I have 2 factors that can cause it to be division by 0. But then because it's a word problem, I also have an implied restriction. So first thing is monomial, it can't be 0. Second thing is subtract 1, it can't be -1. Now x, if we go back over here, x is the speed of her warm-up. Now I can't do a negative speed. So my implied restriction is that her speed has to be greater than or equal to 0. Now let's put these all together. This is speed, has to be positive, but it can't equal 0, so I'll change this to be greater than 0, and it can't be -1. Well, that's included with the x greater than 0. So actually, this restriction will do us for all of the question. Whatever my answer is for x, or my value for x is, it has to be greater than 0. So now that I've established that, let's create a common denominator using my 2 factors. Okay, so let's compare each one. So looking at my first one, I have a factor of x. I'm missing x plus 1. So I'm going to multiply top and bottom by x plus 1. So that's 4x plus 4. In the next one, I'm missing a factor of x. So I times top and bottom by x, which is 4x. So let's add those together, which is 12x plus 4 over x times x plus 1. And then I just want to simplify because I noticed that my numerator has a GCF of 4. Now, I know right now it's not going to help me because I see it doesn't simplify anything, but I always want to do it because in case it can be simplified, I always want it to be in factored form. And then I will say that is the total time of her race, 4 times 3x plus 1, all over x times x plus 1, where x is greater than 0. Okay, let's talk about Joey Chestnut. If you don't know this, there is a whole sport and it is called competitive eating, and Joey Chestnut is into professional eating of pizza and hot dogs, probably most well known for his hot dog eating. Now he has just captured his 13th mustard belt by eating a record 75 hot dogs and buns in 10 minutes in the 2020 Nathan's Hot Dog Eating Contest. This is an actual thing. And I actually went on the internet to get pictures to capture this in a 3-stage process. So I just want to show you those. There he is eating, and he's just like shoving them in his mouth. Right here he's at 68, but we already know he went up to 75. As I would probably feel after 68 hot dogs, he's starting to feel sick, but if you throw up anything, it doesn't count. So he's almost there, and he captures it. Yay, he's a-okay. So this is an actual thing, professional competitive eating. So I want to use this idea as a little fun twist to do a question with rational expressions. So at Nathan's Deli in New York City, there's an annual hot dog eating contest. Now suppose you can eat an average of n hot dogs per minute. For me, that would be 1. For you, maybe it would be more. After eating 5 hot dogs, your average rate of consumption slows down by 1 hot dog a minute, and I hope so. After 5, I would definitely slow down. So I want to write and simplify an expression showing the number of minutes it would take you to eat 10 hot dogs. So 10 hot dogs. So we're eating 5 hot dogs at a constant rate of consumption, and then after those 5 hot dogs, I slow down. So I'm taking those 10 hot dogs and I'm going to split them into 2 parts. The first 5 and the second 5. So this is what I'm going to do in my expression. So my first set of hot dogs, my first set of 5, I eat at a consumption of n hot dogs a minute. So 5 hot dogs divided by however many hot dogs I can eat per minute. Plus the next 5, I slow down by 1 hot dog per minute. So if I was eating 3 hot dogs a minute, I'm slowing down to 2 hot dogs a minute, etc. So let's talk about our restrictions. Well, our restrictions in the denominator, we can't divide by 0, so n can't be 0 and n can't be 1. But I know that n has to be greater than 0 because I can't eat a negative number of hot dogs. And n also has to be greater than 1 because if I'm decreasing the number of hot dogs I eat by 1, I have to at least be eating 1 to begin with. So my overarching restriction for this whole entire question is that n has to be greater than 1. So let's come up with lowest common multiple, and then we will add these fractions together. So lowest common multiple between n and n minus 1 is 1 of each. So I'm going to change each one into the lowest common denominator, and then we can simplify. So in the first fraction, I'm missing a factor of n minus 1. So I'll multiply the top by n minus 1 as well. In the bottom, I'm missing a factor of n, so I multiply top and bottom by n. So adding these together as a common denominator, I have 5n plus 5n is 10n minus 5. And then I'll just factor out a common factor of 5 to be 2n minus 1 all over n times n minus 1. So if you know how many hot dogs you can eat a minute, you can substitute that value for n in here, and this will tell you the number of minutes it would take you to eat 10 hot dogs. So since this professional hot dog eating is such a big thing, I entered Mateo into the Nathan's Hot Dog Eating Contest. It was when Cross Iron Mills opened in 2020. True story, Nathan's Hot Dogs came to Cross Iron Mills and had a live hot dog eating contest. So Mateo won the hot dog eating contest in his class in 2020. In this video, or in this picture here, he is age 3. Guess how many hot dogs my little boy ate to win? Any guesses? Any guesses? Half a hot dog. He ate half a hot dog because he decided halfway through he didn't like the ketchup on the hot dog. But he still won in his class because other kids didn't even eat any hot dogs. So this will be a nice little picture that I can show at his wedding when he won a hot dog eating contest. So this is the end of word problems with fractions. In math, we can have improper fractions. The boy says, Susie said my fractions were improper, and then she slapped me. Improper as in not proper, or in terms of math, improper where the numerator is greater than the denominator. You guys can go ahead and do practice questions 4 and 5, detailed solutions on D2L, and then go on to your homework question. Watch out for improper fractions. And I'll see you for the next video.